All right, section 8.4, we're going to be introducing you to trigonometry and the right triangle trigonometry. And in this video, I'm going to show you how to use that to solve right triangles, both missing sides and missing angles. So first of all, I want to introduce you to the trigonometric ratios of sine, cosine, and tangent. Abbreviations that we use for these are SIN for sine. It's not sin. It's referred to as sine. COS is the cosine, and TAN is the tangent. You'll notice that all three of these here, I have the sine of angle A, the cosine of angle A, and the tangent of angle A. All of your ratios are going to be based off of having one of your angles of your triangle, with the exception of where your right angle is. So angle A here, that's going to be our reference angle. Now we have to talk about the different sides of your right triangle, which all have different names. The one name that does not change is your hypotenuse. Sorry, it's kind of, let me go back here. All right, so here's your hypotenuse. And your hypotenuse is always going to be the longest side of your triangle. It's always going to be opposite of your 90-degree angle. The other two sides are based off of angle A, and the first one that I'm going to talk about here is the side, or the leg here, that is opposite of angle A. So this side here is opposite of angle A. The side leg over here on the other side, this is going to be our adjacent leg to angle A. And so adjacent means next to. So when you're talking about angle A, you have two sides of your triangle that are next to angle A. You have the hypotenuse and side AC here. But your hypotenuse right there, that's always going to be named the hypotenuse. So you're talking about the adjacent leg. Now, if you were to look at angle B, you'd be switching things up here. The side here, which is opposite of angle A, would be adjacent to angle B. Over here, the adjacent leg to angle A would be the opposite side of angle B. Now, your three ratios here get created, and we'll talk more about this in class tomorrow, but the sine of angle A is always referring to your opposite side over the hypotenuse. Your cosine is the adjacent side over the hypotenuse. And the tangent is going to be your opposite over your adjacent. All right, so it's with these three ratios here that we are going to be able to now solve missing sides and missing angles. A way to help you remember these three ratios is we have this kind of acronym here of SOHCAHTOA, SOHCAHTOA. So when you see SOH, it's telling you that you're taking the sine of an angle as the opposite over the hypotenuse. C is representing the cosine, so cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So what I'm going to do here is I'm going to give us a right triangle that has all the three sides to it. And we're going to find the 6 trigonometric ratios that can go with this triangle here. Notice that the first 3 right here are dealing with angle N, and the second grouping of 3 here are all referring to angle L. So the sine of angle N, so talking about the sine, we're talking about the opposite over the hypotenuse. So the opposite leg to angle N is going to be 15. The hypotenuse is 17. So its ratio here is 15 over 17. Talking then about the cosine. Cosine is the adjacent leg over the hypotenuse. So that would be 8 over 17. Tangent is going to be your opposite over your adjacent. So we're going to go to the opposite side here of 15. The adjacent leg here is going to be 8. Those are the 3 trig ratios to go with angle N. Next, if I look at angle L, looking at these 3 ratios, they are going to be different. Angle L here, opposite of angle L is side 8. The hypotenuse is still 17, so its ratio is going to be 8 over 17. Looking at the cosine, we're going to take the adjacent leg here over its hypotenuse, so it's 15 over 17. And then lastly, we're going to be looking at the tangent, which is the opposite over the adjacent, so that would be 8 over 15. So those are the 6 trig ratios that we can use for a right triangle here. Now, how are we going to use these to be able to solve for missing sides? Well, you're going to have a scientific calculator. You're going to be using sine, cosine, and tangent. And what you have here is you have a right triangle, and we have this angle of 64 degrees. That's what I'm going to refer to as your reference angle. Now, when I look at this angle of 64, I'm going to look for which side of the triangle is given to us. And what they're telling us right here is that we have the adjacent side. And the side that we're trying to find over here is we're trying to find the opposite side. So if I look up at SOH, CAH, TOA, looking at if it's sine, cosine, or tangent, and which of those is going to be working with the adjacent and opposite. The adjacent and opposite is working with tangent. So I can set this up as the tangent of 64 degrees is equal to the opposite side of x over the adjacent side, which is 12. Solving for x, I'm going to go ahead and multiply both sides of my equation by 12. This now gives me that x is equal to 12 times the tangent of 64 degrees. So I'm going to go to my calculator and I'm going to type in 12 times the tangent of 64 degrees, and I'm going to hit enter, and 24.6 is my answer. So x equals 24.6, and there's our answer. Setting it up with a trig ratio and then solving for x. Another example. Here again, a right triangle. I have a reference angle of 39 degrees. I'm given the opposite side to that, and we're trying to find the hypotenuse. So if I look for which trig ratio is dealing with opposite and hypotenuse, that's our sine function. So we're going to be taking the sine of our angle of 39 degrees is equal to 60 over x. Now, unfortunately here I can't just multiply both sides by 60 because 60 is not in our denominator. We have to multiply both sides by x to get x out of our denominator. So now it's x times the sine of 39 degrees All right, so we have x times the sine of 39 is now equal to 60. And now to solve for x, I would divide by the sine of 39 degrees. So go to your calculator, you're going to take 60, we're going to divide it by the sine of 39 degrees, and then you get 95.34. And that's how you solve for missing sides of right triangles. Now, what if we have to find out what a missing angle is? Well, using your trig ratios here, we're going to use a function on your calculator. It's called the inverse function, and that's what's going to help us figure out what the angle is. So here I have the ratios that are associated with angle ABC here. To find out what angle B is, I have 3 options. I can use the calculator to do what's called the inverse sine of 30 over 34. And what that's going to do here is that's going to tell me what angle B is. So onto our calculator, I'm going to go second sine, and I'm going to take 30 divided by 34. and then go ahead and hit enter, and I get 61.9 degrees. Now if I do the same thing with cosine and tangent, so if I do the inverse cosine of 16 over 34, I'm still finding an angle, and I'm still finding the same angle. So hopefully I get the same answer here. So the inverse cosine of 16 over 34 ends up giving you 61.9. So I get the same answer no matter what ratio. If I were to do the inverse tangent of 16 over 34, I'm going to get 61.9 as well. Now on the next ones here, working with angle C. Now I'm going to get a different angle because it's a different angle of your triangle. Doing the inverse sine of 16 over 34, notice it's a different ratio than what we put into the calculator up above. And so if I do the inverse sine of 16 divided by 34, I'm going to get 28.1. Now I could do the inverse cosine, I could do the inverse tangent, and both of those are going to end up giving me the exact same answer. Now these answers, they should add up to 180 degrees, the fact that you already have a 90-degree angle. So these two angles that I'm coming up with should add up to the remaining 90 degrees. So going over an example, here's a right triangle where I'm trying to find x. Here's x. Notice that I'm given the opposite side and the hypotenuse. So here's the opposite side, here's the hypotenuse. Of SOHCAHTOA, the one that deals with opposite and hypotenuse is your sine function. So I can set this up as the sine of x is equal to 24 over 37. Solving for your angle then, we're going to take the inverse sine of 24 over 37. So now go to your calculator, do the inverse sine of 24 over 37, and we get 40.4 degrees. Going through another example here, one more. Here you're trying to find x once again. I have the adjacent leg as well as the hypotenuse here. So adjacent and hypotenuse would be the cosine. So the cosine of x is equal to 7.2 over 14.8. To find an angle, we're going to take the inverse cosine of 7.2 over 14.8. And here I'm going to do inverse cosine, 7.2 divided by 14.8. And there we have 60.9 degrees. And so here we just spent a couple minutes just to figure out how to find missing sides and missing angles of right triangles.